In this video, I want to talk about a hobby project that I've been doing. In this project, I run a functional mock-up unit of an unmanned ground vehicle in ROS2. The UGV has a chassis model, tire-to-ground contact model, and also there is an electric motor for the wheels on either side of the robot. I have used PID controllers to control the speed of these motors. This is the final result. I use arrow keys on my keyboard to run the robot forwards and backwards and to also steer it. I started by building the robot model in Maplesome. This is the model layout. I have used some dummy inputs for the testing purposes. Another block gets the inputs and generates set speeds for the motors. And PID controllers try to follow those set speeds by getting the measurements from the plant model as well. The main piece that I'm going to use from this model in ROS is the UGV subsystem. This subsystem gets voltage from the PIDs and applies it to DC permanent magnet motors. There is also some sensors for measuring the actual speed of the motors. The chassis subsystem includes a simple chassis geometry, mass inertia, and the tires. Next, I generate an FMU of the UGV subsystem to use in ROS. This is a graph representation of my ROS2 workspace. The teleop node publishes my key entries to CMD well topic. setCMD node subscribes to this topic and then calculates and publishes set speeds for motors. Motor PID nodes publish motor voltage values by subscribing to the set and measured motor speeds. Finally, the UGV FMU sits inside the FMI Adaptor node. I have used FMI Adaptor package to run the FMU. You can find the source code for this package in the video description. Okay, so let's see the project in action. As you can see in the terminal window, I've already built the workspace. In a new terminal window, first I source a setup file. Then I'm going to launch the file that I've specifically written for launching the required nodes. Next, in a new terminal window, I run the teleop node to get my keyboard entries. On the right, you can see the visualization of the FMU generated real-time by Maplesome Insight. Notice the 3D playback as well as the plots for motor speeds and voltages and how those are changing as I press a new key. As robot doesn't have any steering mechanism, it actually steers by applying different torque values on the wheels on either side. This is also known as differential steering. Alright, this wraps up my video. I've included the link for the source code of this project in the video description. Feel free to drop a comment if you're interested and want to discuss more.